Welcome back, everyone. Today we're going to talk about a lesser known capability of the vibrometers, which is to measure strain. Let's get to it to keep this nice and short. So I'm going to break it down into two different components. One is strain measurement and another is strain monitoring. As we go through the differences between the two, you'll see the differences in components as well. So first of all, measurement is more related to steady state conditions, whereas monitoring is more transient, more time variant conditions. Measurement is more about full field when it comes to vibrometry. So you're getting a full field data, whereas monitoring is more appealing to people who are trying to replace a strain gauge for various limitations associated with the strain gauge, like the frequency range and the temperature performance. And there are also some basic goals that dictate what kind of technology you'll use. So strain measurement, which is a full field technique, is more associated with modal analysis, material characterization type stuff, whereas strain monitoring has its roots sort of motivation into high cycle fatigue or very high cycle fatigue, which is more common now, which is about standards that dictate how many cycles, so high cycle fatigue being 1 million and very high cycle fatigue being 10 million cycles. So that's how these two vary. And finally, the strain measurement, because of the scanning principle, is more about continuous repeatable excitation, whereas monitoring can handle both, whether it's repeatable or non-repeatable. And so this kind of gives you the pros and cons of both techniques, whereas you get a full field type response using the 3D scanning vibrometer and strain measurement, whereas you get 1 point, but you get time variant, non-repeatable excitation response and fatigue data with strain monitoring type applications. Now, in the last slide, I just have a couple of examples. On the left, you see the full field data set, and this is, might look like, vibration data, but it's actually strain data. This is collected using our strain processor, which is an accessory, a software accessory to the scanning LDV. On the right, I had to tilt the plots there to make it fit in the slide. But you can see on the bottom, we have a couple of, pictures as well that show the location or the gauge length between the two laser dots that we are measuring, the in-plane vibrations. The two plots are on the top. We have the raw in-plane vibration data. So we use this to calculate our delta L in the strain equation. And then knowing L, we can calculate what's on the bottom, which is the actual strain data. So hopefully this kind of helps you understand the differences between the two and also the capabilities of the system that is a vibrometer in terms of strain measurement. It's a very powerful tool. We've been doing it for a long time. Reach out if you want to give it a shot, give it a try. Thank you very much for your time and attention. Thank you.